Good morning to all of the students. Today in this video lecture we will discuss about the beta functions. The object of this video is to introduce the concept of beta function and its numerical application. So first of all we focus the definition of beta function. Beta functions, which is also known as Euler equation of first kind. Euler's equation of first kind, which is also known as Euler equation of first kind. So first of all, let us notice the definition of beta function. We define definition. If m and n are positive integer, then beta of m and n is denoted by beta of mn and defined as 0 to 1 x raised to the power m into 1 minus x raised to the power m n minus 1 dx. This is the definition of beta function in terms of mathematics. Now we want to discuss here some property of beta function that's very useful in the numerical problems. Property of beta function. First property is beta of mn is equal to beta of nn. It means the beta function does not depend the order of the argument. It means beta of 1 2 is equal to beta of 2 1. That is the symmetrical property. Of beta function. This is the most important property of beta function, that is the beta function is symmetrical in their argument. It means the beta function does not depend the order of argument. And second property is beta of mn is equal to factorial m minus 1 factorial n minus 1 divided by factorial n plus m minus 1. Now the next property is that is the third property, beta of mn is equal to integral 0 to infinite y raised to the power m minus 1 upon 1 plus y raised to the power m plus 1 dy. That is the integral property of beta function. It is very useful in the numerical problems. And fourth property is gamma n into gamma 1 minus n equal to pi upon sin n pi. And fifth property is gamma 1 plus n into gamma 1 minus n equal to n pi upon sin n pi. These are the property of beta functions that are very useful in the numerical problems. Now we want to discuss next topic is the relation between beta function and gamma function. What is the relation between beta function and gamma function? The relation between beta and gamma function is beta of mn equal to gamma m into gamma n divided by gamma m plus n. This is the most important relation between beta and gamma function. That is the relation between beta and gamma function. This is the most important property. There are so many questions can be asked in the examination on this property. Then we want to prove it. Proof. In order to prove this property, we will use the previous result. Since we know that gamma m into gamma n equal to 2 times into gamma m plus n integral 0 to infinite sin h to the power 2m minus 1 theta into cos h to the power 2n minus 1 theta d theta. It means in order to put this result, we will use this formula. Now, first of all, we want to evaluate this integral. Now, 2 integral 0 to infinite, 0 to pi by 2, 0 to pi by 2 sin raised to the power 2m minus 1 theta into cos raised to the power 2n minus 1 theta d theta. First of all, we want to evaluate this integral. What is the value of this integral? In order to evaluate this value of integral, we substitute, put sin square z equal to theta. We put sin square z is equal to theta. Sin square theta is z. Now differentiate 2 sin theta into cos theta d theta equal to z. If we substitute sin square theta is z, then the limit of integral will be, if theta is 0, this implies z is also 0. If theta is pi by 2, this implies theta is 1. It means the limit of integration will be changed 0 to 1. Now we substitute this value. Then integral to 0 to 1 sin square theta is z. It means sin raised to the power 2m minus 1 theta into cos, it means 1 minus sin raised to the power n 2n minus 1 into dz. We can write sin theta into cos theta is d theta. Sin theta into d theta into d. It means 2 sin theta and cos d theta is dz. So this will be reduces to 0 to 1 z raised to the power 2n minus 1 z raised to the power m minus 1 into 1 minus z raised to the power n minus 1 dz. This integral will be 2. If we use the previous result in this previous section, then the value of this integral will be converted the beta of mn. Beta 1, that is the trigonometrical representative, that is the definition of beta of mn. So by using this result, equation first will be reduces to, therefore gamma m into gamma n equal to 2 gamma m plus n into beta of mn. Now we find the value of beta of mn. This implies beta of mn equal to gamma m into gamma n divided by gamma m plus n. This is the complete proof of this relation. It is the most important relation That is the relation between beta and gamma function. Now next we take some numerical problem on these properties. First question is, evaluate the following. Evaluate the following. A is gamma minus 1 by 2 and second is B gamma minus 3 by 2. Solution. In order to evaluate this gamma function, we use following property or following formula. Since we know that gamma n into gamma 1 minus n equal to pi upon sine n pi. In order to evaluate this function, we use this formula. In order to get gamma minus 1 by 2, we put n equal to minus 1 by 2. Then this formula will be reduced to gamma minus 1 by 2 into gamma 3 by 2 equal to pi upon sine minus pi by 2. This formula will be this. This implies gamma minus 1 by 2 into gamma 3 by 2 equal to sine minus theta is minus sine theta and sine pi by 2 is 1. This implies minus pi. Now we find the value of gamma minus 1 by 2 equal to minus pi upon divided by gamma 3 by 2. Now we evaluate the value of gamma 3 by 2 since gamma minus 1 by 2 equal to minus pi and gamma 3 by 2 will be open as 3 by 2 1 by 2 into gamma 1 by 2.